So welcome to all of you. So today we will see what we mean by a relation. Okay. So in the last lecture we have seen what we mean by sets, right? All the types of the set, operation on the sets. We have seen all that. We have seen also that how to find a cross product of the two sets. Okay. So that is what cross product of set means. What we have to take the all order pairs, right? So order is important there. So first element should be from the first set. That is what here we have seen that this is what A cross B. So this is the set of all order pairs AB. Why it is called order pairs? Because the way of writing the element is very important here. So A must be from the first set and B must be from the second set, right? So if you write like this is what? This is the pair, but this is not the order pair. This is not the order pair because what we can write this as BA also. Okay. So this AB is same as, but here what? This AB is not same as BA now. This AB is not same as BA. Okay. So this order is because what here? A is the element from the set A. B is the element from the set B. So therefore it is called order pair. The order is very important, right? The first element should be from the first set. Second element must be from the second set, right? So therefore it is called order pair, and set of all order pairs is nothing but A cross B, right? Now same thing here, what? The relation is also defined on the A cross B like this. Okay. Suppose X and Y are two non-empty sets. Okay. Let X and Y be two non-empty sets. Then a relation R from X to Y. The relation R from X to Y is the subset of X plus Y. X cross Y. That means what? Any subset of X cross Y is a relation from X to Y. So if I take this as what? Suppose this I will take this is what? A is equal to A, B, C, D suppose. Okay. I will take B is equal to, you can take capital X and capital Y also. 1, 2, 3, 4, 5, whatever this. Okay. So if I draw this like this, suppose this is what? A, B, C, D here. Okay. So now this is what? 1, 2, 3, 4, 5. If I like this, if I consider this, whatever this, you can take any this. So what is this? So this is your X, this is your A, and this is your B. So now this set is what? So now A is related to 1, A is related to 2, A is related to 2. So this is your R. Suppose this is what? Suppose this is R. Then I can write this R as R is equal to A is related to 1 and 2. Now what about B? B is related to 3 and B is related to 4. B is related to 4. Okay. What about C now? C is related to 2, C is related to 5, C is related to 2, C is related to 5. What about D? So D is related to 3, 4, 5. D is related to 3, D is related to 4, D is related to 5. Okay. Now this is the relation from A to B. This is nothing but because this is a subset. This is subset of A cross B. How many elements are in A cross B? There are 4 elements in A and there are 5 elements in B. So your A cross B is what? A1, A2, A3, A4, A5, right? B1, B2, B3, B4, B5, C1, C2, C3, C4, C5, and D1, D2, D3. See here. Now we have not taken all the elements from A cross B. We have taken the some elements from A cross B. That means what? All these elements are in A cross B. All the elements of R are in A cross B. Now this is a subset of A cross B, and any subset of A cross B or any subset of X cross Y is a relation from X to Y or relation from A to B. Now this is a subset of, this is R is a subset of A cross B, right? So this is what? R is a subset of A cross B. R is a subset of A cross B. So R is a relation. R is a relation from A to B, right? So now here what? A1 belongs to R. A1 belongs to R. So we can write this as, A is related to 1. A is related to 1. So similarly you can write A is related to 2, B is related to 3, B is related to 4, and so on. Okay, so in this way we can write this is what A is 1. So A is related to 1, right? That means A is related to 1. See here, so this is the Venn diagram of this relation. Okay, so that means you are here A is related to 1, A is related to 2, like this you can write it, right? So whatever this relation, this you notation, you can write any notation R. You can take a tidal also. Tidal is also there. This is called tidal, right? So if I write this is what A tidal 1. So that means what your tidal is a relation from A to B. This is a symbolic representation of the tidal. Okay. So if tidal is, I can write this is what A related. So X tidal 1 means what X is related to 1. You will relate this, right? But your relation R is nothing but this symbol, right? So that means what here X is related to Y. That means what XY belongs to tidal. So whatever this X and Y the sets are given, that depend on this word X and Y. Okay. So I hope that you understand what is meant by relation. Relation is just what any subset of x cross y, any subset of x cross y, right? Is a relation from x to y. So from what x cross y, your first set is what x and your second set is y. So x from y, x from y. So then what if R is a relation from x to y, then x is called domain, and y is called codomain of the relation R. Okay. So the first set is nothing but a domain, and the second set is first. So that means what? Suppose this is what x, and suppose this is y, and suppose this is 1, 2, 3, 4. This is what? Suppose A, B, C, D, E, F, G. What? E, F, G. And if I write this like this, whatever this. Okay. So this. Okay. So now suppose this. So now what is this? The A image of 1 is what? A, B, C. That is what A is called the image of 1. B is called the image of 1. E is also called image of 1. Right? B is called image of 1 to 4. Right? And this is what also C is called image of 3. D is called image of 3. E is called image of 1. F is called image of 4. So these are the images of these elements. Right? So I can write this as what? So image of 1 is what? A here. Okay. So now this is called a pre-image. That means 1 is the pre-image of A, B, E. 1 is the pre-image of A, B, C. So reverse the reaction. So these are called pre-images, and these are called images of these elements. Okay. Now, okay. So that is what you are. I think you understand this one. What you mean by image and this what? Image of 1 is what? These are the images. Actually, images of 1 are 1 A, B, E. Image. There is only one image, right? So B is the image of 2 is what? B. Images of 3 are what? C and D. Images of 4 are B and F. Okay. So these are images and other things. Okay. So we'll see the types of the relation. So first is what? Reflexive. This is very important. Reflexive. So first type is the reflexive relation. Okay. Okay. Let X be a non-empty. Non-empty set. So X be a non-empty set means what? It has at least one element. Okay. A relation. Just will write the small number. What? A relation R from X to X is called reflexive is called reflexive if for all x belongs to x implies that x is related to x. So that means what? Every element is related to itself is called a reflexive relation, right? So that means what? Image of 1 is 1. So here what? X cross x. It is what? Subset of x cross x. Such way that what? X is related to x. That means every element has every related to itself. That means what? Suppose I have taken this relation. So 1, 2, 3, 4, 5. Okay, so now this is 1, 2, 3, 4, 5. You have to take both the sets are same now. Okay, now this is the relation. Okay, this is the relation from x to x. So we want to reflect. Suppose I have drawn this. Okay, I did like this. Suppose. Okay, now we check whether this relation is reflexive or not. So when we say that a relation is reflexive, if every element is related to itself, that means what here 1 is related to 1. Okay, so 1 is related to 1. Yes, 1 is related to 1. Now here what 2 is related to 2. Okay, okay. We don't bother about the other thing now. Okay, so only our condition is what every element should related to itself. This is our the condition, right? No matter 1 is related to other, so that is not a part of the definition now. Your definition is what just every element should related to itself. Now check whether every element is related to itself or not. Right? Don't bother about the other relations. Okay. So now here what 1 is related to. No, don't. So this is not a part of our definition. Our part is what whether you have to check every element is related to itself or not. Okay. So your 1 is related to 1. Your 2 is related to 2. Your 3 is related to 3 here. Check 3 is related to 3. 4 is related to 4. 5 is related to 5. So this R is reflexive. This is what R is reflexive. Reflexive. R is reflexive. Suppose I have given this relation. Suppose this is what x square plus y square is equal to 1. Okay. So your R is what? The set of all xy belong to R2 such that this. Okay. R is the what? Set of all xy belong to R2 such that, so I will write it. So R is what? Suppose this R is relation. Okay. So xy belong to R2. That means what? This is R cross R. Right? So this relation R cross R. Okay. Such that x square plus y square is equal to 1. So means what? This is, so that is what? So xy belongs to R. Belongs to R. Means what? X is related to x. So x is related to y. Okay. So x is related to y means what? X square plus y square is equal to 1. When x is related to y, if the sum of that square is 1, if sum of the square is 1. Now, whether this relation is reflexive or not, whether this relation is reflexive or not. Okay. So that means what? The x is related to x means what? Okay. So x is related to x implies that x square plus x square is equal to 1. Is it true? Right? So this is what then twice x square is equal to what? 1. So x square is equal to 1 half. Right? So that means what here? X square is equal to 1 half now here. So so square of every real number is what? Half. The square of every real number is half. Then x is related to x, right? So that means what here? So this implies that x is not related to x. X is not related to x. Therefore, this implies that R is not reflexive. So here what your set is R. Now see, 1 square plus 1 square is also not 1. Right? That means what? The sum of the square of the sum of the square of the number and the itself is not 1, right? For every element. So that means what? Every x is not related to x. So that means what? Because here x square is, you should get 1 now. If x square is equal to 1, then the x square plus y square, that is what? 1. Okay. So that means what? This is not a reflexive relation. So for reflex is what? Every element is related to itself. Then the second type, symmetric relation. Okay. Second, this is definition is very important. symmetric relation. Okay, so write the same definition. Let X be a non-empty. Let X be the non-empty set. Let X be non-empty set. Okay, a relation R from X to X, or you simply say that word, a relation R on X. A relation R on X. Simply you can say, or from X to X is said to be symmetric. Is said to be symmetric if for all xy belongs to X. For all. This is the symbolic representation of for all. No need to write the spelling of for all, right? Just write down this symbol. This for all xy belong to X. That means what, for any xy belong to X, X is related to Y, implies that Y is related to X. So Y is related to X. So that means what here? Whenever your X is related to Y, Y is also related to X. Now this is a relation on the same set now. So that means what? Suppose we have given this A, and suppose this is A here. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So I will take this relation. Okay. So now this is for all xy. That means what here? For all xy belong to R, X is related to Y is related to X. This should hold. Okay. So is it true for all? Now check this. What? 1 is related to 2 and 2 is related to 1 now here. Okay. So 1 is related to 2, 2 related to 1. Right? So that means what? X is related to 1, Y is related. Now here see that 3 is related to 5, 5 is related to 5 is related to 5 is related to 3, 5 is related to 3, 4 is related to 6, right? And 6 is related to 4 now here. Okay. So now here what? 5 is related to 3 and 3 related to 5, right? That means X related to Y related to X. 6 related to 5 and 5 related to 6. So we have this 5 related to 6. Okay. Now this is the symmetric relation. Okay. So we'll see later on this examples on it. So suppose we'll take one example so that your idea will be clear. Okay. So I'll take one example. Suppose this R1. Suppose this is R1 or R. This is what? 1 1. This is 1 1. 2 2. 3 3. 4 4. I take another relation R2 as 2 2 2 2 2 4 2 4 4 4 4 4 4 2, and your A is what? Your A is 1 2 3 4 1 2 3 4. I will take another relation A3 such that 1 1 1 1 1 2 2 1 1 3 3 1. Oh, 3 3 3 3. Okay, now we check whether this relation is a symmetric or not. 1 is related to 1, 1 is related to 1. No problem here. So this is what identity. This is what reflexive relation is always symmetric relation. No problem for this. Right? This is reflexive. This is what 1 is related to 1. This is identity relation. Okay. So X is related to X. Right? This is true for all X now. Right? So that means this is the symmetric relation. Now here what? 2 is related to 2, 2 is no problem here. Now see, this is 2 related to 4 is there. 2 related to 4. Check whether 4 is related to 2 is there or not. Yes, 4 is related to 2 is there. Right? 2 is related to 4. 4 is related to 2 is there. Right? So that means what? X related to y related to x, right? This is given, right? Now 4 related to 4, no problem here. What? Again 4 related to 4. So this is this is symmetric relation. This is symmetric relation. Okay. Now what about here? No problem for one. Now see here. This is what? 1 related to 2. For all x, y, this should be hold for. One, check whether 2 is related to 1 or not. Check whether 2 related to 1 or not. Yes, 2 is related to 1 is given now. Here what? 1 is related to 3 is there. But check whether 3 is related to 1 is there or not. So 1 is related to 3 is there, but 3 related to 1 is not there. So that means what? Here what? 1 is related to 3 does not imply that 3 is related to 1 here. So that means what? For every x, y, x is related to y, there does not exist y related to x. That means what? X related to y does not imply that y related. That means what? This is not a symmetric relation. Because what? 1 is related to 3, but 3 is not related to 1. So 3 is not related to 1 here. So this is not a symmetric relation. So I hope that you understand the definition of the symmetric relation now. Okay. So in the next session we will we'll solve number of problems on the reflexive, symmetric, and this. Now next type is what? Transitive. Transitive. Third one. Transitive relation. Transitive relation. Okay. Let X be the non-empty set. We write the definition. Okay. So definition. Let X be a non-empty set. Okay. A relation R on X we write it. Okay. Instead of R from X to X we write R on X. Is transitive if for all x, y, z belong to X. For all x, y, there are 3 elements. So X is related to Y is related to Z, implies that X is related to Z. Okay. So that means what? Whenever X is related to Y and Y is related to Z, then what? X is related to Z. If such thing is hold here and there, then that relation is called a transitive. That means what? X is related to Y related to Z, then X is related to Z. Okay. So then that relation is a transitive relation. That means what? Suppose I have taken this relation. Suppose the set of R real number. I have taken the set of the real number now. Okay. So if I define this X like this, what? Set of all x, y belong to this R2 now this, because what? Any subset of R cross R is nothing but a relation. So I will write this is what? X is less than or equal to Y. That means what here? So therefore what? This relation is what? X is related to Y implies that X is less than Y. So when X is related to Y, if X is less than Y. Okay. Now we will check whether this is reflexive, whether this is symmetric, whether this is transitive, whether this is reflexive. Okay. So since what? X is less than equal to X. Because of this less than equal to, we may write this in, right? So this implies that X is related to X. This implies that R is reflexive. Okay. Is it symmetric? X is less than or equal to Y does not imply that Y is less than or equal to X. Right? X is related to Y means X less than or equal to. X less than or equal to Y does not imply that Y less than or equal to X. This implies that R is not symmetric. Okay. Now is it reflexive? Suppose X is related to Y. Suppose X is related to Y. Y related to Z. Okay. Suppose this. Okay. Now X is related to Y means what? X less than or equal to Y. X less than or equal to Y. Y related to Z means what? Y is less than or equal to Z. So what does this imply? This is implies X less than or equal to Y. Y less than or equal to Z. And what does this imply? X is less than or equal to Z. So X less than or equal to Z. That means what? This implies that X is related to Z. Right? So whenever we have X is related to Y, Y related to Z, then what? X is related to Z. That means what here? So therefore R is transitive. R is transitive. So we'll take one more example so that you will understand the definition of the transitive. Okay, so we'll take examples. So I'll take example. So suppose A is equal to 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I'll take relations. We'll check whether that relations are transitive or not. Okay, so we have given these three relations. We check whether that relations are transitive or not. Okay. Now check here. This is identity. This is identity. Every element is related to itself now. So this is reflexive. This is symmetric. This is transitive. That means if this is the identity relation is there, then this is always symmetric, always reflexive, always transitive. Okay. So now we'll check the second one now. So this is what one is related to identity relation. No problem for this one. Now see here. One is related to two. Okay. Now see. This is what one related to two. Okay. So check whether 2 is related to 1 or not. So 2 is related to what? 2 is related to here, 1 is there, 2 is related to 2 is there. Okay. Okay. So now what we have? 1 is related to 2 and 2 is related to 1 there. Right. Now check whether 1 is related to 1 or not. 1 is related to 1. Okay. If I take this one, 1 is related to 2 related to 1. Now 1 related to 1 is there. Yes, 1 is related to 1 is there. Right. So okay. Now 1 related to 2, 1 related to 2, 2 related to 2 now here. Okay. Now check 1 related to 2 is not 2 is there or not. Yes, 1 is related to 2 is there. Right. Okay. So this happened for 1. Okay. Now here what then? 2 related to 1 and 1 related to that is over now. 2 is related to this is identity. Now here what? 3 related to 2. 3 related to 2. Now check 2 related to. So 2 related to here 1 is there. Okay. Now 2 related to 2 is there. 2 related to 2 is there. Okay. Now we'll consider these two now. We'll consider these two. 3 is related to 2. 2 is there. Check whether 3 is related to 1 is there or not. So 3 related to 1. Yes, 3 is related to 1 is there. Okay. So that means what? This is over. Now we'll take 3 related to 2 and 2 related to 2. Check whether 3 is related to 2 is there or not. Yes, 3 is related to 2 is there. Okay. So that means what here? That means what here? 3 related to 2, 3 related to 2. So we have, so that means what? So this is what for all x, y, x, y, z now. Now we take 3 related to 1 now. We take that relation 3 related to 1. We check that reflexive or not. Okay. So this should be hold for all x, y, z. 3 related to 1. Okay. So I write 3 related to 1. Okay. So 3 related to 1. Okay. 3 related to 1, 1 related to we'll check. 1 related to 1 is there. Okay. So 3 related to 1. 1 related to 2 is there. 1 related to 2 is there. Then what? 3 related to 1. One more thing. No. Okay. So only these are there. Only these are two possibilities are there. Okay. 3 related to 1. 1. X is related to y. Y related to z. We have to take all such type of the triplet only. So now what this implies? We have to check whether this is hold. 3 related to 1 is hold or not. We have to check. 3 related to 1 is there. Yes, 3 related to 1 is there. Okay. Now 3 related to 1, 1 related to 2. So what should be there? What should be there? 3 related to 2 should be there. Okay. So we'll check whether that is there or not. So 3 related to 2 is there. Yes, 3 related to 2 is there. That means what? This is the this is transitive. This is transitive. Okay. We'll take one more. One by one. We'll go for one by one now here. Okay. We will take this one, take this one, take this one, take this one. Okay. Now this is what I will take 1 related to 3 now. Okay. I will take this. Now I will take 3 now. 1 is related to 3. So 3 is related to. I will take the images of 3 now. So 3 is related to 2. The only possible pair is there, one is related to 3. So check whether these two, what should be there? 1 is related to 2 should be there. If it is transitive, then 1 is related to 2 should be there. Check whether it is there or not. Yes, that is there. So this is whole. Okay. I will take then 2 related to 3 now. 2 related to, okay. So I will take 2 related to 3. Okay. So for this pair, the relation hold now. Okay. So I will take now 2 related to 3. So for 2 related to 3, I will take the images of possible images of 3. 3 related to 2 is there. Okay. There is only one possible pair is there. What should we want? 2 related to 2 you want. Okay. Now check whether 2 related to 2. 2 related to, is there 2 related to 2? 2 related to 3. Yes. And 3 related to is there. But 2 related to is not there. But 2 related to is not there. So therefore what? Okay. So since what? 2 related to 3, 3 related to 2 does not imply that 2 related to. Therefore R is not transitive. R is not transitive. Okay. So in this way you can check whether your relation is transitive or not. Now next, equivalence relation. Equivalence relation. Okay. Okay. So let definition. This is very important. Okay. Definition. Let X be a non-empty set. Let X be a non-empty set. Okay. A relation R on X is said to be an equivalence relation if R is 1 reflexive, second symmetric, R is reflexive, symmetric, and third transitive. Okay. So when we say that relation is a equivalence if R is reflexive, symmetric, transitive, it should, all three should hold. If that relation hold reflexive, symmetric, and transitivity, then that relation is equivalence relation, right? So a relation which is reflexive, symmetric, and transitive is called a equivalence relation. So this is very simple definition of the equivalence relation. Okay. So remember, this is what reflexive. Reflexive is what? X is related to y, x is related to x for all x, y belongs to x, right? So reflexive is what? So x is related to x for all x belong to x. Okay. And symmetric means what? X is related to y implies that y related to x. Okay. And transitive means what? X is related to y related to z implies that x is related to z. Okay. So this is the, okay. No need to write all of this. X is related to x and this one. So just simply write what? A relation on x is said to be an equivalence relation if it is reflexive, symmetric, and transitive. Right? All three should happen. All three should be hold for that relation. If the relation hold all three properties, all three these conditions of reflexivity, symmetric, and transitivity, then that relation is called equivalence relation. Okay. So in the next session, we will see the number of problems on the equivalence relation. So if you solve the problems on the equivalence, automatically you have to solve the problems on reflexivity, symmetry, and transitivity. Right? Automatically you are going to solving the problems on these three relations. These three relations. Okay. So I hope that you understand the symmetric relation, reflexive relation, and transitive relation, and what is meant by equivalence relation. This is the just definition of the equivalence relation. Okay. So if you want to show that it is equivalence, relation, just you have to prove that relation is reflexive, that relation is symmetric, and that relation is transitive. Okay. So we'll stop here.